Alright, welcome back guys. We're going to be looking at section 7.2, and as you can see this is on transformations. We actually saw some transformations or types of transformations when we were talking about symmetry. So for example, when you have y-axis symmetry, like think of a parabola from a quadratic function, one side of that parabola is reflected about the y-axis to get the other side. Well, that is a transformation. And basically what's happening there, let me go ahead. Actually, you know what? We've got a picture of it right here. See? X squared. So this is our parabola right here. Well, this piece on the right-hand side, or vice versa, is just a mere reflection about the y-axis of the corresponding piece. What's actually happening to have all these points on the left-hand side reflected is that their x-coordinates are changing sign. Okay, so all the negative x-coordinates are positive over here. That's where we get that symmetry. That's what creates that symmetry. But that is an example of a transformation. Okay, and what we're going to be looking at today more specifically is, let's say we have a set of basic functions like I have right here that you can see. So we could say of all of the quadratic functions, our basic quadratic function is f of x equals x squared, or y equals x squared. Okay, you guys remember we kind of get away from using the y equals notation and we use the function notation. Well, x squared, that is your most basic quadratic function. Okay, it gives you a parabola that's centered right at the origin, or right in the middle. Now when we start modifying this, like if I were to add a number out here, then I would be performing a transformation on this basic function. And I want to give you an example. So I'm going to pull up Desmos here, and we're going to type in y equals x squared. Okay. Alright, now let's look and see what happens if I add a number to this. Let's say I say I want to add the number, plus and then 2. Did you guys see that? Actually, you know what? Why don't we do both of these? Why don't we have the basic function graphed, and then we'll do another one in which we do some transformations. So x squared. Okay. Now let's say plus. We'll say plus 3. Look at that. Look at the one in blue. It is still a parabola, but it's shifted up 3 units. What's happening is 3 is being added to all the y-coordinates of all the points that make up the parabola, and that's what shifts it up. What if instead of adding 3 I subtract 3? Well, now look, it shifts downward. Okay. Or what if, let's see, what if I put a negative sign in front of that x squared? Let's see what happens. It turns it upside down. Basically what happens there is all of those y-coordinates change sign. They all become negatives. Where I'll show you one last transformation that we're going to work with. What if, let's see, what if I keep this square, because that's what makes it quadratic, but instead of adding 3 out here to the end, I put a plus 3 in parentheses next to the x. Look how it gets shifted or transformed horizontally. Or what if I now say minus 3? Now it's shifted to the right. Okay, so these are the things that we're going to look at today. All right. Whoops. Okay. All right, so let's see. In this section we're going to see how just a handful of functions can be used to obtain almost all the different functions that we see in this course, and that's true. The next section we're going to study quadratic functions in more detail. Well, all those different quadratic functions are just transformations of this basic x squared. Okay. It says these are basically permutations or transformations of these few basic functions. So let's look at them, guys. Look right here. So for example, the graphs of f of x equals x squared and g of x equals x squared plus 3 are very similar. Well, we saw that. They're both parabolas because they're both quadratic. One is just shifted up 3 units. Okay. Alright, so we're first going to look at this set of basic functions. A lot of these we've seen. Our basic linear function, guys, is just y equals x, or f of x equals x. Okay, that's our basic linear function. Now, when we start transforming it, if we have something like y equals 2x plus 3, then it's still a line, but it's transformed. It's going to be twice as steep, because the slope here is 2. And the y-intercept would be 3, so it would be shifted up 3 units. Okay, at least at this one point. Okay. And then we haven't really discussed this function yet. We will in this module. It's the square root function. What it does is whatever you plug into it, it takes the square root of it. And look at the graph of this function. Notice it doesn't exist over here when x is negative. And if you guys remember from your previous math courses, that's because we can't take the square root of a negative number. Okay, so it only exists in the upper right quadrant. Okay, and it has this shape. And then we've also seen some cubic functions. Okay, but our basic cubic function is just y equals x cubed. If we start adding numbers or manipulating this, as long as the x cubed part stays in there, it'll be cubic. And then here's an example of a cube root function. So what this function does is, instead of taking the square root of whatever you plug into it, it takes the cube root of it. So let me give you an example here. If I were to plug in the number 8, the cube root of 8 is a number such that when you cube it, gives you 8. Well, that number is 2, because 2 times 2 times 2 is 8. So we could say the cube root of 8 is 2. Or in other words, when x is 8, y is 2. So that's what this function does. And it does exist when x is negative, because you can take the cube root of negative. And the reason is because when you cube a negative, you get another negative. Okay. And then we've seen this one before. They call this a reciprocal function, basic reciprocal function, 1 over x. Remember, that function had a restriction on its domain at 0, didn't it? That's why it's split right here whenever x is 0. And then finally, guys, we've also seen that absolute value function. Okay. When you guys were graphing these, you were actually looking at some transformations. If it was shifted to the left or right or up or down, those were transformations of this basic function right here, which is centered at the origin. Okay. So anyway, that's what we're going to discuss today. All right, so manipulating these functions how creates what types of transformations? That's what we're going to look at next. All right, so I'm going to scroll down. So what would cause a vertical transformation? Similar to what I was demonstrating in Desmos over here. Let me change this back. X squared, oops, and then let's say plus 3. Okay. Oops. Okay. Well, to obtain a vertical transformation, it says, if you look right here, it says when b is greater than 0, it says the graph of y equals f of x plus b is the graph of y equals f of x shifted up b units. Well, that's what we just saw demonstrated. I've also got a graphic right here. if f of x is this function right here, 1/5 x to the 4th, and this is its shape, or this is its orientation here, it's kind of like a parabola. Hold on just a minute, guys. Okay. Well, I imagine we're still recording, but I am frozen. That's okay. Yeah, so if you're looking at this function, it looks like a parabola, but it's actually kind of a widened parabola. But if this were our function, and if we add 5 to it, it shifts it up 5 units, and we obtain this one that's in red right here. Or similarly, if we start out with that same, this is a 4th degree polynomial, by the way. If we start out with that same function in black and we subtract 3 from it, then it shifts it down 3 units, and we end up with this function in turquoise. Okay, and that's what I was showing you in Desmos. See, if x squared is our basic quadratic function, and we add or subtract some number, that simply just shifts it up or down. Let me show you a couple other examples in Desmos real quick. Let's think about just a linear function. There's our basic linear function. Okay, and we'll add or subtract a number from that. So x minus 2. Well, look at the blue line. It shifted down 2 units, isn't it? Or what if I say plus 5? Now it's shifted up 5 units. Okay. Let's try another function. How about that reciprocal function, 1 over x? Okay, so we know it has this shape in red, 1 over x. But if we add or subtract some number, I'm going to add the number 3 at the end. Look, what we have in blue is that same function in red shifted up 3 places. In other words, guys, the y-coordinates of all the points that make up that function, they increase by 3, or they decrease by whatever number. Okay, so in short, if there is a number out to the side of your function, that will yield a vertical transformation. Okay, now how do we obtain a horizontal transformation? Well, it says right here, the graph of y equals f of x minus d, and notice this is in parentheses, is the graph of f of x shifted to the right d units. Or the graph of y equals f of x plus d is the graph of f of x shifted to the left d units. And we've got a couple examples down here. So again, we're using the same basic function, but notice, what if we put in parentheses, we keep the x in parentheses, we still have it to the 4th power, but that exponent's on the outside, and we put a number in there with the x, like a minus 3. Then that shifts it to the right 3 units. Okay, see how it's centered over here at 3? But what if inside those parentheses there's a positive number, say x plus 7? And that shifts it to the left 7 units. This is the opposite of what you probably would intuitively guess. Intuitively, you would probably think if there's a negative in there with the x, it's going to shift it to the left. But it actually goes to the right. Okay. And then right here it says, note, when the constant is negative, the function shifts to the right, and then it shifts to the left when the constant is positive. Guys, you've got to remember that. Let's look at a couple other examples here in Desmos. Now, if our basic function is 1 over x, for a reciprocal function like this, you would see the number, it wouldn't necessarily be in parentheses, but it would be in the denominator with the x. So you can see when I put in a +3 down there, it shifts it, it's this blue one right here, it shifts it to the left 3 places. Or if I put a -3, it shifts it to the right. Okay, let's try another one. Let's just do let's do a cubic. We haven't done, so here's our basic cubic function. But if we keep the x in parentheses and put a number in there and then cube it, whoops, then it shifts it to the left 2 units. What if we change that +2 to a -2? Now it shifts it to the right 2 units. Okay, so that's how you're going to obtain a horizontal transformation. All right, now there's one last type of transformation that we're going to talk about. It's referred to as a reflection about the x-axis. Okay, so where is the x-axis? It's the horizontal axis, right? Put in here our good old quadratic function. Okay. Okay, so a reflection about the x-axis means it's like it has x-axis symmetry in a way, okay? But what happens is the function is reflected about that x-axis. So in other words, it turns upside down, guys. All the y-coordinates of all those points become negatives. They change sign, in other words. Okay. That's what this means right here. It says the graph of y equals negative f of x is the reflection of the graph y equals f of x across the across the x-axis. Okay. Here's some examples again. So if this is our basic function in black, if we stick a negative in front of it, it turns it upside down, or in other words, it reflects it about the x-axis. Because what's happening is all those y-coordinates that are coming out of this function are now negatives. That sticking a negative in front of it changes their signs. And that's what I mean right here. It says if a point xy is on the graph of your function, then x negative y will be on the graph of negative f of x. In other words, if you stick a negative in front of that function, it changes the sign of all those y-coordinates. Okay. Now, you don't have to worry about the second bullet point. Okay. What would cause a reflection about the y-axis? Okay, you don't have to worry about that. You're not going to see that in this section. But here's some pictures that I found that have symmetry, but they have horizontal symmetry. See that? The reflection, all these reflections in the water. So you can sort of think about this as being the x-axis, and all these points that form the image above the water, they're transformed. You can give all their y-coordinates negatives, and you'll get this reflection, this image below, okay, or this image from the reflection of the water. So anyway, and here's another example. Don't worry too much about that one. Let's look at Desmos real quick. So if I stick a negative in front of the x squared, look what happens. Turns that function upside down. And then we're going to get into, well, what if there's multiple transformations? Okay, so what if we have some number out to the side, that shifts it up 3, and then what if we have, in parentheses with the x, another number? Well, then that shifts it to the right 2 units. So here we have both a vertical and a horizontal transformation, and then if we stick a negative in front of it, it turns it upside down. So we actually have 3 transformations. So this function right here is just a transformation of that basic quadratic function. Okay. And when you become familiar with that, guys, you can see some really, I guess, complex looking function, and you can see, you'll be able to notice that, oh, well, it's just really a fourth degree polynomial, where it's just a, it's just a quadratic function. Okay, so you'll know the shape of it, and furthermore, you can start to pick out how it's going to be transformed, and consequently its orientation, without ever actually having to graph it. And so that's kind of what we're trying to get at in this section. Okay. All right, so we've gone over the three transformations that we're going to see: a vertical, a horizontal, I'm counting with my fingers as if you can see me, but and a reflection about the x-axis. Okay. All right, so now what we're going to do, and I think we'll wait for the part 2 video to do this, but now we're going to put all of this together. Or in other words, they're going to give us some function, okay, like example 1. They're going to ask us, this is a transformation of which of those 7 basic functions that we saw up here, and then furthermore, what is the transformation or transformations? And then they're going to have us graph it. Okay, and you'll have to graph these in your homework as well. All right, we'll do that in part 2. We'll finish this up. I've got several examples. Okay.